Everyone, in this very video we are going to quickly look at mesh analysis. A particular example of mesh analysis. You can do well to click the subscribe button below there, to get more notification of our classes. Now we see a question here, we see a network here using mesh analysis to determine the mesh currents and the node voltages. I want us to note this first of all, that in mesh analysis, the current passing through a particular resistor is depending on the direction of current of our loop, direction of loop current. Okay, so that means in this 1 ohm resistor, the current passing through 1 ohm resistor is I1 because that's the loop passing through it. But when you see this other 1 ohm resistor here, you can see that it is in between I1 and I2. So the current passing through it is going to be either I1 minus I2 or I2 minus I1, depending on the loop we are considering. Now look at this 2 ohm resistor here. We can say that the current passing through it is the loop current, which is I3. But this 2 ohm resistor here is in between two loop currents, which is I2 and I3. According to mesh analysis, the current passing through the 2 ohms resistor is I2 minus I3 or I3 minus I2. Now, we should also note that that is just the difference between mesh analysis and Kirchhoff's law. So the Kirchhoff's law remains, but that's what I just explained now gives us the difference between them. Now let's see, let's take loop 1. Now remember, according to Kirchhoff's law, that the summation of the EMFs is equal to the summation of IRs. Okay, so if you consider loop 1 with the 6 volts resistor the 6 volts EMF, that's going to be minus 6 because the direction of the loop is going from the positive to negative, is going positive to negative. Now equal to the IR for the 1 ohm resistor here. This 1 ohm resistor here, we're going to have 1 into I1 minus I2. Remember, it is I1 minus I2 because I'm interested in loop 1. Okay, then plus the other resistor here, which is this, has just I1 attached to it. So we are going to get 1 times I1. Okay, so which when we open the bracket, we'll get minus 6 equal to I1 minus I2 plus I1. Okay, so that means minus 6 is equal to 2I1 minus I2. Okay, so you can write that somewhere. Minus 6 equal to 2I1 minus I2. So that takes us to the second loop, loop 2. Okay, so you can see that the voltage, remember, we still have summation of EMF is equal to summation of IR. So the voltage there, the loop is going from negative to positive, so it's going to be 12. It's positive, so equal to, for this 1 ohm resistor, is going to be 1 into, since we are dealing with loop 2, it's going to be I2 minus I1. We are dealing with loop 2 here. Now plus, for this 2 ohm resistor here, is going to be 2 times I2 minus I3. Okay, so that means we are going to get 12 equal to I2 minus I1, opening the bracket, then plus 2I2 minus 2I3. Okay, which if we should rearrange, we are going to get minus I1. I2 plus 2I3 gives us 3I2. Okay, then minus 2I3. You can write that somewhere. 12 equal to minus I1 plus 3I2 minus 2I3. Okay, now let's consider the third loop, I3. The total voltage here is 6, is plus 6, because if you follow the direction of the loop, you see it is going from negative to positive, so it's positive. Okay, so we have plus 6 equal to, for this guy here, only I3 is passing through it, so we have 2I3. Now plus, for this other guy here in that loop, you have, it's going to be 2 into I3 minus I2. Remember, it is I3 minus I2 because we are considering loop 3. Okay, so we have 6 equal to 2I3 plus 2I3 minus 2I2. Okay, so that means that 6 is equal to I3 minus 2I2, and we can write that there. That 6 equal to 4I3 minus 2I2. So you notice here that we have three equations. Let's list the three equations. Now the first one is that 2I1 minus I2 is equal to minus 6. The second one is that minus I1 plus 3I2 minus 2I3 is equal to minus 12. Okay. Then the third one is 4I3 minus 2I2, okay, let me equal to 6. Okay, so we are supposed to solve these three simultaneously, and when we solve simultaneously, okay, sorry, this is plus 12, not 12. Okay, so if we solve that simultaneously, we are going to get I1 to be equal to 1 amperes, I2 to be equal to 8 amperes, then I3 to be 5.5 amperes, or you say 11 over 2, so 5.5 amperes. So we are done with the mesh current. So that's the mesh current. So, but I want to go further here by saying that if you want to find, let's say the current through this 1 ohm resistor, like we say, is already I1, and I1 is 1 amperes. If you want to find the current through this 1 ohm resistor, like I said, is either you say I2 minus I1 or I1 minus I2. So since I2 is bigger, we can just simply say I2 minus I1, which is 8 minus 1, which is equal to 7 amperes. In the same way, with this 2 ohm resistor, you can say I2 minus I3 or I3 minus I2. So since I2 is bigger, we can say use I2 minus I3, which is going to give us 8 minus 5.5, and that is equal to 2.5 amperes. Now that is very, very easy. Now don't forget, whether we use I3 minus I2, I2 minus I3, the only difference is that it will change the direction, it will be negative. Okay, so you note that depending on the direction of current. Now for us to know the node voltages, remember that from what we can see, V1 already is equal to minus 12, because that's the only voltage in this arm. The only voltage source in this arm is V1, so V1 is minus 12. We don't have a problem with that. And then we can see that the current I2, like we know, V1, the current passing through I1 is 1 ohm resistor. Okay, and that current I1, current passing through the 1 ohm resistor is supposed to be V1 minus V2 divided by the resistor 1. Okay, so if you multiply, the current is also 1, so 1 equal to V1 minus V2 over 1. Okay, so that gives us V1 minus V2 equal to 1, and V1 from what we saw here is 12, so 12 minus V2 equal to 1. So that means V2 is equal to 12 minus 1, which is equal to 11. We did that since I2 is greater than I1, so we assume that the current here is moving this way. So because I2 is greater than I1, so that's why we have V1 minus V2 all over 2. Now V2 here, what of V2? Another way we can find V2 is exactly the voltage across this 2 ohm resistor, because that's the only resistor in that arm. So another way you can do that, you can say that the current through the 2 ohm resistor is equal to V2 all over the resistor itself too. Now the current here passing through the 2 ohm resistor, remember, like we said, is I3 minus I2 or I2 minus I3. Okay, depending on the one who is bigger, and we got it to be 2.5. Okay, so we can say 2.5 equal to V2 over 2, and that is giving us V2 is equal to 5, so 5 volts. And the same thing with V3, we can find V3 since the current across V3 is also the voltage across this 2 ohm resistor, and the current passing through V3 is I3, which is 11 over 2, or you say 5.5. So we can say that 5.5 which is the current, is equal to V3 all over 2. So that means V3 is equal to 11 amperes. V3 is equal to 11 amperes. Thank you very much. I ask that you click the button below to subscribe to get more of our channel. Thank you very much. Have a wonderful day. Okay, I correct a mistake quickly. Let's see this again, the current here. We said that the current passing through the 1 ohm resistor is either I1 minus I2 or I2 minus I1, which we actually got to be 7 amperes. Okay, so that is 7. So we have 7 equal to, we have V1 minus V2, okay, all over the resistor is 1. So we have 7 equal to, remember what we got for V1 is 12, then minus V2. V2 is what we are looking for. Okay, so we can now have that V2 is equal to 12 minus 7, which is equal to 5 amperes. To confirm that, alternatively, like I said earlier, just to repeat again, we can also say that V2 is the voltage across this 2 ohm resistor, since that's the only resistor in that arm. So you can say the current passing through the 2 ohm resistor is I2 minus I3, or I3 minus I2, which gave us 2.5. okay, so we can say 2.5 is equal to V2 all over 2. So that means V2 will be 2.5 times 2, which is equal to 5 amperes. Thank you very much.